This video will be about the derivatives of logarithms and natural logarithms. So when you're working with logarithms, we know the derivative is log base a of x equals 1 over x times the natural log of a. And for natural logs, the derivative's a little bit simpler. Derivative of a natural log is just 1 over x. So given alone, they're not too especially difficult, but usually they combine them, so you have to do product rule or chain rule as you're working with these. So for example, let's say we have natural log of natural log x squared, and we want to find y prime. So this is a chain rule within a chain rule. So we've got to work our way from the inside out. So the very, very inside is x squared. And the derivative of that will be u prime, or 2x. The derivative of the outside natural log, so we have natural log u, will be 1 over u. Then we'll need the derivative of this inside and the derivative of this outside. So I'm going to call the inside natural log x squared. So v prime here is chain rule. Derivative of the outside, 1 over u, evaluated at the inside was x squared, times the derivative of the inside, so times 2x. If we simplify, we have 2x over x squared, which would just give you 2 over x. And then derivative of the outside again, we have natural log v, would just be 1 over v. So we have derivative of the inside, that was where we got the 2x down here, evaluated at the, sorry, I said that backwards. Derivative of the outside, natural log, evaluated at the inside, x squared, times the derivative of the inside. That's how we got this derivative. And now we can do that again, but with this outside natural log. So we don't need this anymore. It was to help us to find this derivative. So now we do derivative of the outside. Again, it's 1 over v, but we've got to evaluate at v, so 1 over natural log x squared. So that's the derivative of the outside evaluated at the inside times the derivative of the inside, so times 2 over x. We can write this a little bit simpler as 2 over x natural log x squared. So if you don't like doing the actual separate u's and v's, you can just kind of do it all in one go. I'm going to change it just a little bit. So we still work our way inside out. Derivative of this outside evaluated at this inside times the derivative of this inside, so derivative of 2x minus 1 is 2. So that gives you the inside stuff derivative. And then we have to do it again, derivative of this outside, 1 over, evaluated at the inside, so this is all of the inside now, so natural log 2x minus 1 times the derivative of the inside, and that's what we just found, so 2 over 2x minus 1. If we simplify, we get 2 over 2x minus 1 times natural log of 2x minus 1. So it can be helpful to split it up to keep track of the little details, but it can also get confusing because there's so many little details. We also can have problems with our logarithms. So again, this is a chain rule problem. We do only have one instead of two. Part of the problem on the last two problems is doing two chain rules at once. Kind of gets tricky as to what part you're doing. So this one we only do chain rule once. So we know this is the inside. We know the log 3 is the outside. Log 3 of stuff is the outside. So we do derivative of the outside. Derivative of log 3 is 1 over, and usually it's x ln a. X is our inside stuff because we're evaluating at the inside. A was the base of our logarithm. So we would have 1 over, evaluating at the inside, 3x squared minus 5x, times natural log of the base, which was 3. So that's derivative of the outside, evaluated at the inside, times the derivative of the inside. Derivative of 3x squared minus 5x is 6x minus 5. Now if you could simplify, you would. There's no way to really factor this to get anything to cancel though. So the most we can do is just write it all together as one fraction. So one more type of problem. Let's say we have a whole bunch of things multiplied inside our logarithm. So we have this x squared times this cube root of 5x minus 1. So two things. When we do derivatives of roots of radicals, we usually rewrite them in rational exponent form. So I'm going to change this to a 1/3. Then we can use the properties of logarithms to split this up. That way we're not going to have to do product rule and stuff. So the properties of logarithms states is if you have a log or a natural log, works for either, and inside you're multiplying, you can actually split it into two separate logarithms with a plus sign. The multiply changes to plus. You cannot do this backwards. On this problem, there is a minus. That cannot change. We cannot split this into two separate logarithms. You can only do it if it's multiply or divide. Divide would change to minus. So we have natural log of x squared, natural log of 5x minus 1 to the 1/3. A second property of logarithms states that you can take the exponent on the inside and move it to the outside in front of the logarithm. So this becomes 2 natural log x, and this becomes 1/3 natural log of 5x minus 1. So now we can take our derivative. So the first one's pretty simple now. 2 is a coefficient, so it's not really going to affect anything, and natural log x is 1 over x. So this would become 2 over x. Well, the derivative, sorry. We are taking the derivative at this point. If we take the derivative over here, again, 1/3 is a coefficient, so it's going to stay there. We do have to do chain rule this time. Derivative of the outside is 1 over x, but we're going to evaluate at the inside. So evaluate at 5x minus 1 times the derivative of the inside, so times 5. Simplifying, we'd get 5 for the top of our fraction, and 3 times 5x minus 1 for the bottom. They may distribute the 3 in, they may not. So just be on the lookout to see if the answer is the distributed version or if it's just left as the factored form. So hopefully that answers all your questions on taking the derivatives of logarithms and natural logarithms.